Okay, so I'm back again. So just like I said, measurement bias happens when there's an error or an issue with a machine that we are using to record data or individual that recorded data. So an instance can be where we have a team of data collectors, to record data about some projects or some measurements. And then maybe say we have 5 people, for instance. Maybe out of these 5 people, 4 are well trained and have enough experience or adequate experience, and the fifth person somehow does not have adequate experience. And so these are measurements, you know, because it's not trained and not adequately experienced, these are measurements is not critical enough to ensure that measurement is as is. And then there is an element of bias in that, so which eventually record the data, that somehow is so high to influence a green light when we have an aggregate, of all data recorded. And then the project was passed, but eventually along the line, we have to realize that, there's a measurement bias. The data is not as the record taking is not as accurate for the measurement as it should be. You understand? So, but how do companies handle this? How can we prevent, if I in this kind of a scenario now, I'm involved in this project and then I have seen this happen, I will I will do a memo to my manager and then explain the circumstances based on what I can see from the recording, and give do an explanation of what I can see in the report, in the data that we have gathered, and how it's going to impact, the result of what we want to achieve, the model that we want to create. Because it's like a garbage in, garbage out. If the data which is the basis of the model that we want to produce is not it doesn't have integrity, then we are not likely to have an error-free model. So if we don't have an error-free model, then it means the business objective, for which we are preparing the model is not going to be served. So I will iterate all those. I expect there will be a template, or I will design a template like that myself, where I put all the key measures, down, and then enter my thoughts against all the key measures, and then send the report to my manager. I'll make a suggestion. Subsequently, there are various ways, you know, whereby this can be prevented in a future exercise. Number one, we can use multiple measuring devices. If we use, for instance, if we have multiple measuring devices, for collecting data, we will we will find out if 2 or 3 devices are used, say 2, 3, or 4 devices are used. Out of 4 devices, measurement of 3 devices are in agreement, and then there is a third device that seems to be having variated, values from the remaining 3. At that point, we want to question it and say, investigate further. Why is the measurement from this particular device, at variance with the other one? So it means we can quickly, before we go further in the project, we can quickly investigate that and then nip that error in the bud. Another way by which we can by which we can avoid measurement bias is by, employing statistical procedure to identify and eliminate outlier in measurements and ensure that it doesn't cause bias in our project. Then yet a third way of doing that is in a situation like the instance that I explained, when we have observers, to collect data, we want to ensure that all the observers or all the investigators are adequately trained uh, and have the prerequisite experience before they are deployed to collect data. We want to be sure their training and their experience will have ensured that they know what is bias and they know all forms of bias and they know how to avoid all those in their measurements. So that is the way we can handle measurement bias. Then the next question is talking about explain the difference between regression and classification models in predictive analysis. Yeah, regression essentially is a model that is measuring a quantity, whereas classification is a model that wants to predict category. Regression is a model that wants to measure or predict a quantity, whereas classification is a model that is predicting a category. Example of classification model are clustering or segmentation model. K-means, for example, is a typical example of a classification model, which is used very well in market segmentation, where we can there are centroid we can plot values about subgroup, groups based on in marketing. Essentially, you have customers based on you track customers based on some what do I call these factors? I've forgotten these factors that I want to measure. Essentially, factors are tracking stuff like age. I want to use a general term. I've forgotten suddenly. Factors like age, income group, demographic factors. Collected demographic factor indices about customers, and then you want to segment them because you want to target them in marketing separately because consumers vary, based on their demographic factors, and often in marketing, how you are going to target customer A if he or she has a different set of demographic factors from customer B should be different. Otherwise, you won't be making optimum result from marketing. So, clustering is a typical example. An example of which is K means is a typical example of a classification model. Whereas a typical example of a regression could be is the time series data that we just talked about, because essentially we have a quantitative value, over time that we want to predict. We historically we have data about the variable, quantitative variable, and we want to predict future values. So that is clearly an example of a regression model application. So when will you choose one of these models over the other? Yes, just like I explained, I will choose a regression model. And a typical example is when I want to do, like say I want to predict, a model, a time series data. Typically, that is a regression model application. If I need to do a market segmentation procedure, that is typically a classification model application. So the next question is saying, I think essentially those are all the questions. Those are all the questions. Those are all the questions. So thank you very much. I'll upload these videos of the answers and then send them to you.